Alright, in this video we're going to look at the last three examples from the chain rule part 1 lesson. We'll start here with example 7. We're going to find the derivative of y equals the sine of the quantity x cubed cosine of x. So sine is my inner function here, and x cubed cosine of, or pardon me, sine is my outer function, and x cubed cosine of x is my inner function. So when I find the derivative, I'm going to take the derivative of the outside, leaving the inside the same. The derivative of sine is cosine. I'll leave the inside the same. And then I'm going to multiply that times the derivative of the inside. The derivative of x cubed cosine of, or pardon me, x cubed sine of x. And now to take the derivative of that part, we need to apply the product rule. So we still have our cosine of the quantity x cubed sine of x up front here. And then we will apply the product rule to x cubed sine of x. So we've got x cubed times the derivative of the sine, which is cosine, plus sine times the derivative of x cubed, which is 3x squared. And now I'm going to clean this out, factor out what I can. I can factor an x squared out in front of everything. And so this turns into x squared times the quantity x cosine of x plus 3 sine of x times the quantity cosine of the quantity x cubed sine of x. And there's our derivative in number 7. Alright, number 8. Y equals tangent of the quantity 3x squared minus 5 over the secant of the quantity 3x squared plus 7. This one looks like it's going to get ugly for us. So I'm going to go ahead and apply the quotient rule here. So we've got dy dx equals low times the derivative of high. And when we take the derivative of the tangent, we need to apply the chain rule. So we've got the derivative of the outside, which is secant squared, leaving the inside the same, times the derivative of the inside. Alright, so we've got low d high minus high times the derivative of low, the derivative of secant of the quantity 3x squared plus 7. We're going to have to apply the chain rule again. We take the derivative of the outside, which is secant tangent. So we need secant of 3x squared plus 7 tangent 3x squared plus 7 times the derivative of the inside, which is 6x. We're going to have all of that over the denominator squared, which is secant squared of the quantity 3x squared plus 7. And now I'm going to clean this up. Let's see, what can I factor out of both of these? I've got a 6x in both, and I've got a secant of the quantity 3x squared plus 7 in both. So I'm going to factor that out. So I've got 6x secant of the quantity 3x squared plus 7 times quantity secant squared of 3x squared minus 5 minus tangent of 3x squared minus 5 tangent of 3x squared plus 7. And then in my denominator, I still have a secant squared of 3x squared plus 7. And now I'm going to, since this is a factor of the numerator, I'm going to cancel one of those secants out from the denominator with the secant in the numerator. And we end up with our final answer, which is 6x times the quantity secant squared of 3x squared minus 5 minus the tangent of 3x squared minus 5 tangent of 3x squared plus 7 all over secant of 3x squared plus 7. And that's the end for that one. That one did look a little ugly at the end. Alright, and our last example, example 9, we're going to find the derivative of y equals sine squared of x tangent of 3x. So we want to apply the product rule here first. So we've got that dy dx is equal to sine squared of x times the derivative of the tangent of 3x plus tangent of 3x times the derivative of sine squared of x. We need to apply the chain rule in both of these. First, the derivative of the tangent of 3x. We take the derivative of the outside, leaving the inside the same. That's secant squared of 3x times the derivative of the inside, and the derivative of 3x is just 3. And then we need to take the derivative of sine squared of x. And this is one that gets a little tricky for some people. It's important that you think about sine squared of x as the quantity sine of x raised to the second power, because then when I apply the chain rule to this, the exponent is the outside function, so I take the derivative of the outside, leaving the inside the same. It becomes 2 sine of x to the first, times the derivative of the inside, which is cosine of x. And now I want to clean this up a little bit. Let's see, what can I factor out of both of these? Just a sine of x out of both terms. So I've got sine of x times the quantity 3 sine of x secant squared of 3x plus 2 tangent of 3x cosine of x. And there's the final value for our derivative. So a lot of different ways that we can apply the chain rule. We always have to be paying attention to the order that we're applying these derivatives. You know, is it going to be the quotient rule first, or the product rule first, or the chain rule first? And it all really depends on what the nature of the function is that we have. I told you the little tip that in the last video, I told you the little tip that I use when I'm trying to figure out in more complicated functions what derivative rules to apply. I think about, okay, if I were going to put a value of x into this function and evaluate it, what would be the last step that I would take in my evaluation? Because that's going to be the first step that I take when finding the derivative of these. For instance, in this last one, y equals sine squared of x tangent of 3x, if I were finding the value of that, I would substitute x into both the sine squared and the tangent of 3x, calculate the values of both of those, and then lastly, I would multiply those values together. So that means the multiplication is the first thing that takes place in finding the derivative, hence why we applied the product rule here first. Okay, that's just a little tip from my experience. Alright, that's the end of this video and the end of this lesson. Hope you have a great day and see you next time.